Hello everyone, I'm Chengshuo Xia, a second-year PhD student from Keio University, Japan. Today, I'd like to give the presentation of my submission to the student research competition, Optimal Sensor Position, exploring the interface between the user and sensor in activity recognition system. Conventional human activity recognition system normally serve the users based on fixed position, such as the smartwatch attached to the wrist, the smartphone placed at arm. The uniform sensor position normally cannot satisfy the user's demand according to different conditions. For example, for an injured person, some body positions may be invalid, or a single position causes discomfort in long-term monitoring. However, potential position for sensor placing is wide, both in variable and non-variable type. Different people have different requirements of sensor position, such as, for the designer, they aim to find the position enable a best performance of HAR system, or for the user, they hope to comply with the user's preference. So there are two basic questions. Can I have more options for sensor placing to follow my preference? Where is the most significant study to present the highest accuracy in a given machine learning network? Our study is arose by these two basic questions and try to find the potential interface between the user and the sensor through the user positioning the sensors in an HAR system. This study is going to discuss the sensor position in an HAR system, aims to improve the interaction from the HCI aspect. The user give the conditions related to their requirements of the sensor position. Our study used the position selection method to generate the possible position and the dataset to train the HAR system and finally recognize the human activity. The problem can be abstracted into an optimization problem. The goal is to find the optimal solution. The HAR system is built based on the font position. The traditional method is the classical design orientation method. It is a trial and error approach, just to follow the experience. For example, to design an inertial device-based HAR system, the common position of variability is related to the wrist and the thigh. It can be recognized as a random selection method, and the designer spend less time on determining the position. It just adhere to the previous work or experience. Our study designed a Firefly searching method to generate the optimal sensor positions with user's condition. It is a heuristic searching algorithm and can find the global optimal positions under the given conditions, such as the sensor number and user's preference. It can map the user's preference during the iteration. We conducted the validation. The first is a variable AMU-based HAR system. The user can propose their conditions, like prefer to the waist, dislike the head. And our system shows the better performance in terms of the computational cost and higher accuracy. The design method can also be combined with the simulation dataset to improve the design process. We can apply the virtual sensor in a 3D virtual environment to generate the virtual dataset and use our optimization method to find the best and train the virtual HAR, the classifier, and the position into the real world to recognize the real activity. It is easy to obtain the dataset and conveniently design the HAR system. It can also balance the indoor design and the user's preference in designing a HAR system. This study discussed the sensor position-based interface in HAR system development. It proposed a Firefly algorithm-based optimization. The user's preference can be mapped during the design period. Future work will be concentrated on decreasing the matters of gathering large amount of dataset and try to make a lightweight usable interaction to make a lightweight usable practical testing.